Hello everyone, welcome back to the second session of our module 5, and here we will be discussing about biasness handling and decision making. So in session 2 it is all about bias and detection techniques. Okay, so bias in algorithms refers to the systematic errors that result in unfair or prejudice the outcomes against certain groups or an individual. As we know that algorithms are not immune to bias, right? Okay, so this bias can arise from the data used to train algorithms, the design choice made during development, or how algorithms are deployed. So all of these areas are areas where bias can arise from algorithms, right? Also, detecting and mitigating bias is crucial to ensure that algorithms operate fairly and equitably, right? So let's see different types of different types of bias. So bias in algorithm can come from several sources. Here are three primary sources where bias can occur. The first one is a data bias. So bias can arise from data sets used to train algorithm. So if the data set isn't representative of the population, the algorithm may generate biased outcome. So for instance, we have what we call historical bias, where a data set reflects past societal bias like gender discrimination in hiring. The algorithm will likely perpetuate this kind of bias. Also sampling bias. So if facial recognition system is trained only on lighter skinned individuals, it may perform poorly on underrepresented groups. So bias can occur from what? From data. Another source where bias can occur in algorithm is algorithmic bias, right? So this arises from algorithm design or how it is implemented, right? So it's saying that bias that originates from design and implementation of algorithm itself. This can occur even if the data is unbiased. For instance, feature selection bias. Choosing a feature that inherently reflects bias. For instance, using a zip code in loan approval algorithm can indirectly introduce a racial bias. Another source of bias is a deployment bias. So this occurs when an algorithm is applied in a different context than where it was initially trained, right? Or initially intended. So bias that occur when algorithm is used in a context different from where it was trained or intended. This is what we call deployment bias. Example are contextual bias. So using an algorithm trained in one region or culture in another where it might not apply appropriately, we call it contextual bias. Also, we have operational bias. The differences in how users interact with the system that weren't accounted for during the training, we call it operational bias. So another source of bias in algorithm can occur in a deployment bias. Okay, yeah. So let's see different techniques that we can use to detect this kind of bias. So detecting bias is as important as understanding it. We have several techniques for this kind of detection, right? First one, we have statistical analysis. So by using statistical methods like descriptive statistic, we can access data distribution across various groups to spot imbalance. So statistical method can be used to identify pattern of bias in dataset or algorithm output. Techniques involve descriptive statistic, whereby we analyze the distribution of data across different groups. Also, we have hypothesis testing, whereby we conduct different kind of tests to determine if there are significant difference in the outcome for different kind of what? Different kind of group. This help to determine where the significant difference exists in outcome for different kind of groups. Apart from statistical analysis, we also have a fairness matrix, right? So matrix is specifically designed to assess the fairness of an algorithms. Common metrics include demographic parity. So ensure that the algorithm positive outcomes are equally distributed across different demographics group. Another equal opportunity. Ensure that the algorithm has equal true positive rates across groups, meaning that it should be equally accurate for all group. We also have what we call bias audit. So a bias audit involves a comprehensive review process where an algorithm is systematically tested for bias throughout its development and deployment, right? So this is what we call a bias audit. Steps involve data audit, whereby we evaluate the training data for potential sources of bias. Model audit, whereby we test the model on different subgroups to ensure fairness. We also have outcome audit, whereby we review the impact of the algorithm decision in a real-world setting. We also have a bias mitigation techniques. So techniques used to reduce or eliminate bias once it has been detected. This is what we call bias mitigation technique. Different methods used are pre-processing. So adjusting the data before training to remove bias. Second is in processing, whereby we modify the learning algorithm to minimize bias during training. We also have post-processing, whereby we adjust the model's output to ensure fairness after the model has been trained, right? So this is what we call bias mitigation techniques. We also have ethical review and stakeholders involvement techniques for detection algorithm bias. So engaging stakeholders and conducting ethical review to identify bias that might not be apparent through technical means alone. So this is what we call ethical review and stakeholders involvement, whereby we involve stakeholders on identifying different kind of bias that might not be apparent through different technical means alone. So we need to do ethical review and involve stakeholders. So different techniques in this are user testing, whereby we involve diverse groups in testing to uncover different kind of bias that affect specific demographics, right? Apart from that, we have ethical committees, whereby you are forming a committee that include ethicists, social scientists, and affected communities to review algorithmic decision. So these are what we call ethical review and stakeholders involvement techniques. Okay, so let's see fairness in algorithmic decision making, right? So fairness in decision making is crucial. Algorithm must strive to make decisions that are just, equitable, and unbiased, ensuring no group is systematically disadvantaged. This is especially important in sensitive areas like hiring, lending, law enforcement, and healthcare, right? So fairness in algorithm decision making refers to the principles that algorithms should make just, equitable, and unbiased decision, ensuring that their output are systematically disadvantaged no kind of group. So achieving fairness is crucial in maintaining trust by ensuring that ethical use of technology and preventing harm, particularly in critical areas like hiring, lending, law enforcement, and healthcare. Okay, so let's understand fairness. Fairness means that decision made by algorithm should not favor or disadvantage any individual or group based on attributes like race, gender, age, or socioeconomic status, right? Okay, so there are several approaches to fairness. So let's see different kind of these approaches or types of fairness. First one, you have demographic parity or statistical parity, right? So this statistical parity involve ensure that algorithm satisfy demographic parity if the probability of a positive outcome it's the same for all demographic group. So simply, this approach of fairness means that positive outcomes are equally distributed across demographics groups. Simply, that are what we call demographic parity. What I mean is positive outcomes are equally distributed across demographics groups. Simply. For instance, if a hiring algorithm selects 30% of male applicant, it should also select 30% of a female outcome. That is an example of demographic parity. Positive outcomes are equally distributed across demographics group. We also have equal opportunity, ensuring that the same true positive rate across all of the group. So ensure that algorithm had the same true positive rate across different kind of groups. This is what we call equal opportunity. For instance, a healthcare algorithm should have the same accuracy in diagnosing a condition across all racial or ethnic groups. We also have equalized odds, means that both true positive and false positive rates are equal across groups. It should meet equalized odd if it has both the same true positive rate and false positive rates across all demographics group. This is what we call equalized odds, means that both true positive and false positive rates are equal across all group. For instance, a criminal justice algorithm predicting recidivism should have the same rate of false positive and true positive across all races. Also, we have predictive parity. So predictive parity is simply you're saying that the reliability of a predicted outcome should be equally accurate for all groups. The predicted probability of a positive outcome must or should be equally reliable for all different kind of groups. That is what we call predictive parity. For instance, if a credit scoring algorithm assigns a 70% probability of repaying a loan to individual, it should be equally accurate for men and women. So that's what we call predictive parity, right? Also, we have individual fairness, right? So this simply means that similar individuals should receive similar treatment regardless of a group membership. So individually fair is similar individual receives similar outcome regardless of group membership. For instance, two applicants with similar qualification and experience should have the same chance of getting hired regardless of their races or their genders. So that's different kind of approaches or types of fairness that we have, right? Okay, so let's see approaches to ensure fairness. So we can ensure fairness using various techniques like pre-processing techniques. So pre-processing techniques aim to remove bias from data before it used to train an algorithm. So that is pre-processing techniques. So resampling or reweighting training data ensure equal representation across groups. That are method. Resampling, reweighting, whereby we assign different weight to samples to balance representation, data augmentation, adding synthetic data to underrepresented groups to ensure that the model learns fairly. So these are what we call pre-processing techniques. So apart from that, we have in-processing techniques. So these techniques involve modifying the algorithm itself during training to reduce bias. So methods involved are fairness constraints, whereby we incorporate fairness objective into the algorithm optimization process. Adversarial training, whereby we train the algorithm alongside a second model designed to detect and mitigate bias. Okay, so apart from pre-processing and in-processing, we also have post-processing techniques. So these techniques adjust the algorithm output to achieve fairness after the model has been trained. Methods involved are the ranking, adjusting the final ranking or score produced by the algorithm to ensure fair outcomes. Also, we have threshold adjustment, modifying decision threshold to ensure equal treatment across different kind of groups. Okay, so let's see ethical decision making framework, right? So ethical decision making framework provides a structured approach to navigate complex ethical dilemmas in coding and algorithm development. So these are what we call ethical framework. There to provide a structured approach to navigate complex ethical dilemmas in coding and algorithm development. This framework guides developers and organizations in making choices that align with ethical principles, ensuring that technology is used responsibly and equitably. So there are common ethical decision-making framework. So the first one is utilitarianism. Utilitarianism focuses on maximizing overall happiness, but can risk overlooking the harm to minority. So that's what we call utilitarianism, a consequentiality framework that focuses on the outcome of the decision, aiming to maximize overall happiness or minimize harm, right? So for instance, in a healthcare, maximizing patient outcomes, even if it means trade-off that may disadvantage some individual. So in this utilitarianism framework, principles is the right action is the one that produces the greatest good for the greatest numbers. So this is a principle for utilitarianism decision-making framework. Okay, application are like this. In design a healthcare algorithm, a utilitarian approach will prioritize maximizing patient outcome, even if it means making trade-off that might disadvantage some individuals. Challenge utilitarianism can justify action that harm minority if the overall benefit is deemed greater, raising concern about equity, right? So there is no equity in this kind of decision framework, which is utilitarianism. Also have the deontology, a duty-based framework that emphasizes following ethical principles and rules regardless of the consequence, right? We need to follow ethical principles and rules regardless of the consequence. So no matter if it harms many of the individuals, if it's ethical, if it's ethically good, then you have to follow it, right? So we have to follow ethical principles and rules regardless of the consequence. We are saying that it focuses on following ethical principles regardless of any outcomes. Principles means principles of this deontology. Certain actions are inherently right or wrong, and the individual have a duty to act accordingly, right? So no matter if it harms many individuals, if it's good, it's good. If it's bad, it's bad. So it's either right or wrong. Application. For instance, an methodological approach in data privacy would insist on respecting users' rights to consent and confidentiality, even if ignoring these rights might lead to beneficial outcome, right? Challenge deontology can lead to rigid decisions that might ignore practical outcome potential, resulting in harms, because this one focuses on following ethical principles regardless of the outcome. Okay, we also have a virtual ethics, a character-based framework that focuses on the moral character of decision maker rather than the rules or consequences, right? So centers on the moral character of the decision maker, emphasizing traits like honesty and fairness. Principle is ethical decision are those that reflect virtues such as honesty, fairness, and integrity. Application. Developer might adapt a virtual ethics approach by prioritizing honesty and transparency in algorithmic development, by ensuring that all stakeholders are well informed. Challenge virtual ethics can be subjective, as different cultures and individuals may have different interpretation of what constitutes a virtuous action. Okay, so another decision-making ethical framework is right-based ethics, a framework that emphasizes the protection and the respect of individual rights. So principles of this ethical decision making is that actions are ethical if they respect the fundamental right of individuals, such as right to privacy, freedom, and equality. Applications are like in developing a social media platform, A right-based approach should ensure users' right to free expression and privacy are upheld, even when balancing this right against other concerns like security. Conflict can arise when different rights are at odds, such as privacy versus security, requiring carefully balancing. We also have justice-based ethics. Focus on fairness and equitable outcomes. For instance, these justice-based ethics focus on fairness, equality, and justice in based outcome. The principle is ethical action those that ensure fair treatment and equitable outcome for all of the individuals. For instance, a justice-based approach to hiring ensure equal opportunity for all candidates, regardless of their background. That are examples. Challenge is ensuring fairness can be complex, especially when addressing historical inequalities or systematic bias, right? Yeah. Another, we have care ethics. Stress empathy and the relationship in decision making. That's called a care ethics. A relational framework that emphasizes the importance of relationship, empathy, and care in decision making. Principle is ethical decisions are those that maintain and nurture relationship and consider the well-being of all affected parties. That is called what we call care ethics. For instance, customer service artificial intelligence should prioritize human needs, ensuring that interaction supported users, right? So that's we call care ethics. Challenges, care ethics can be seen as less objective and harder to apply in situations requiring strictly rule-based decision. And this marks the end of the module 5. So see you in the last module to conclude our course by developing practical solution to society challenges. So thank you so much and see you in the next session.